Hi everyone, so today we're continuing looking at simultaneous equations. In particular, we're going to be looking at a graphical problem. So graphical problems, as it suggests, they involve a sort of graph, and we need to either, sometimes use our linear relationships knowledge to find the equation of a line if it's not given already. Using stuff like gradients, we know how to find gradients using the gradient formula, finding our intercepts. Once we've done that, we can find the equation of a line if it's not given already, and then we can either use substitution or elimination to solve those problems algebraically, or sometimes just simply looking at the graph and making an inference is enough to answer the word problem itself. So we're going to have a look at an example here, where we have Ashley, who makes picture frames as part of a business, and to calculate the cost in dollars of making X frames, she uses the equation C is equal to 40 plus 10X, right? And she sells the frames for $20 each and determines her income I in dollars using the equation I is equal to 20X. So you can see over here, we're already given the two equations, and we're given the graph here as well. So this top graph here is I equals to 20x, that's the income graph, and over here we're given the cost graph, so C is equal to 40 plus 10x. So automatically our first step that we're required to do, which is to calculate the actual equation, that's already been done for us. We don't actually have to do that, right? So now what we have to do is we need to figure out how to solve the two equations simultaneously for x, to solve for x. Right, and we also have to make an inference and explain the significance of the solution for Ashley's business. So that's going to be a bit of a worded response. So first, if we have a look at this graph, it's basically asking us to solve the two equations simultaneously for x. So we're trying to find out where, for what value of x, are these two graphs the same, right? For what two values of x is our C and our I the same? That's what we're trying to find, right? So if we look at the solution for this one, here are our two equations again. C is equal to 40 plus 10x and I is equal to 20x. And since we're looking at when these two are equal, we don't actually have to solve this algebraic. We can do that, and it's going to give us the same answer. But it's not a requirement for this. So if you look at these two graphs, we're basically looking for the intersection point, right? And we can quite clearly see here that the intersection happens right at this point here. At x is equal to 4. So that's the number of frames is 4, and the amount of dollars is $80. Right? So that's basically our answer. Our answer is x is equal to 4. That is when these two equations are the same, right? That's when now I is equal to 20x and C is equal to 40 plus 10x. That's when they're equal. What does that mean? At this point, when we sell 4 frames, at that point our income and our costs are equal. So in business terms, we call that the break-even point, which means that Ashley's neither in a profit nor is she in a loss. She's break-even. She's covered her costs at this point. If she sells any less than 4 frames, then we can see that the income line is below the cost line, which means that her costs are higher than her income, right? If she sells any less than 4 frames. But as soon as we get to more than 4 frames, her income starts to exceed the costs, which means that she is now in a profit at any point after selling more than 4 frames. So that's what our interpretation is, that when 4 frames are sold, Ashley's business break even, and she has to sell more than 4 frames for her to be in a profit. Right, so that's a sort of a graphical question that you can sometimes get, and it can sometimes be confusing because if you look at this over here, we don't really have an x and a y variable, right? We only have an x variable there. So using those standard substitution and elimination methods, it's you can't really do that, because how are you going to sub in? Like, what are you going to sub? What are you going to eliminate? What are you going to sub? And there's no two variables that we can really eliminate here. So with this sort of thing, you have to infer what the situation is. In this situation, we're trying to figure out, we're solving for x. So we let these two equations equal each other. And yeah, you can do that algebraically as well. If you were to write 20x is equal to 40 plus 10x. Let's have a look. Is equal to 40 plus 10x. And if you solve that graphically, as we can see here, we'll get the same answer that we've got here. Okay, so that's basically how we sort of solve these equations.